Okay. So in today's class, we are going to look into the Docker section. Any idea what Docker is from your perspective, both of you? Shreya?
Yeah, so like it is like you're making the whole application into a single package where it can be used from anywhere on any kind of an operating system. So that is like
Pretty good. Vishnu, do you have any idea?
No, Akash.
So basically, what the situation was initially that there are multiple different teams, okay, though all of them having independent workflow and having the independent workflow, they were working on a single application. So the same configuration that developer machine having that has to be replicated on all the machines across all the different teams who are working on those applications. So that could include a lot of errors. Okay. If one is using, if developer is using 9.0 version, other QA or any manager is using 7.8 version. So there will be mismatch and a lot of things you will miss out from your application. So to resolve that situation, Docker come into play. So Docker is just a tool. The purpose is the containerizing our application, which is simply a packaging our application into a single format where all your dependencies and configuration would be mentioned in that single package. Okay, and that will be a single portable file format. Okay, which is easily be among shared between all the developers or whatever the team you want to share with. Okay. So that's the main purpose, that to avoid the operating system dependency. Some are in Linux, some are in Windows, some are in Mac OS. All of them initial configuration is different. A single application which builds on a certain technology might work differently on all three the environment. Okay. So the users who are using the application, you don't know what kind of operating system they are using. So in such scenario, you require to provide such a solution that whatever the operating system user is using, regardless of that one, your application run on their system. That's the main purpose of our application builders. Okay. Got it? What is the basic concept of Docker? Okay, containerizing an application. Vishnu?
yes, sir.
Got it, Akash.
Yeah. So where do container lives? That's a very basic questions. Okay. Actually, container always lives inside your storage system. Okay. It requires some storage place where it lives. So we have certain repositories. It could be private repositories, which is your own premises. It could be the public repository, which is the Docker Hub. Now, Docker Hub does not contain the container in the container format. Docker Hub actually contain all this application in image format, not as a container format. When you take that image into your system and then you unpacked it, unpacking and making it live is known as containerizing that one. Means uncontainer. You are just opening that container. More about this one, we'll go deeper and deeper. Okay. For now, this container live in a certain repository. This repository could be your private one, the organization one. Okay. Or you can use the public repository, that is the Docker Hub, just like a GitHub. For GitHub, we use for source code repository. Docker, we use for application repository, application or image repository. Okay. What is this? How? What is the image? Everything will be clear. Just duration of this class. Okay. Yeah. So before container, what the application development used to be like, one is in Mac, a new developer come who is using the Linux system. Okay. So one is having a certain version of certain applications in Mac, whereas other is having certain application, the same application in that one. Okay. So what are the challenges that you need to face? First, the installation process would be different. On Mac, the installation process is different. If you go and try to install any application, you would find three different ways. First for Windows, other for Linux, other for Windows, Windows and Mac OS. So all three, they will provide a different for example, if I go here and go to Jenkins, download. So if you see, they all are giving different scenario to download your Jenkins. Why don't they provide a single file to download in whatever the operating system you have? Why? Because that is not possible. Every environment having different setup on its own configuration. So you have to make your application in such a way that it should be reliable or compatible with all the operating system. How to make? So for that, different configuration required, and that's why you provide different link for different operating system. Okay, you cannot get a single link for downloading for all the operating system. Okay, that's very rare, and that's happened in a very low class of application. If the application is very high, detailed one, you would definitely find different downloadable option for Linux, Windows, and Mac OS. So to come across and many steps somewhere you could go around. Okay, if you are downloading the same stuff in multiple thousands of machine, you will be having a lot of problems because the same version you required and anything can be go mismatch if it is a complex application. So after containerization, what happened? Basically, whatever the configuration we had initially, we converted into a single container. We blocked them into a single container, okay? And that container having certain name. So what issues it resolved? It resolved. Now you have your own isolated environment, okay? The thing is, now anyone does not need to install Postgres SQL or the configuration or any script. They don't have to do everything separately. They'll just do it, download this container on this system and run it. Package all you needed into a single one. So only one member has to do the hard work of packaging, and that member is a DevOps member. Rest member will use that hardware and get the container in the system. So that's how they made it a very simple way to utilize your application in multiple different scenario. Okay. Any confusion so far?
No.
So basically, if I give you a practical example, my own company, okay, so my company does not use Docker, okay, and I was working as a developer. Before DevOps, I was a developer as well. So what happened, our application was a bit complex. So if I have 3 virtual VMs and I have to test one bug, then what I have to do, I have to install that same application, and it was very tricky to install that one into the all 3 VMs. Okay, do the same stuff again, raise that bug. So that's other thing, but installing was a very hectic part. Okay, as a developer, you have a different way to install. As a user, you will be having different way to install. That's other story. But that was a hectic one. I proposed the idea of this one to containerize our application. Okay, but the thing is, so after that, my role changed into DevOps, and then that idea remained an idea. Okay, let's continue. So one command and you install that. That's how easy it is. Now, application deployment. How will you? That's the main purpose of containerizing our application, that it could get deployed very easily. Because before deployment, what was the issues? Developer created all these files, wrote all these scripts for jar file. Developer has to create a script how to download the jar file. For database, how to set up the database, they have to create another documentation. That is the technical documentation. And these files then goes to the operation team. Operation teams read this inscription scripts, and according to that, download the jar file, again read the script and download the database one. Okay, how to configure the database one. And it get complex because you have to read and download, and anything could go mismatch. So what happened? Well, in this, what are the problems you'll face? Configuration on the server needed. First, the configuration you required, a lot of configuration. Dependency conflict versions. Okay. So there could be a versions defectiveness. Like if the developer forget to mention what version of database you have to install, then again, operation team would have problem. Okay, because they at a time you will be having 5, 6 version to install. Again, textual guide of deployment, misunderstanding while writing the scripts. These are human error. Okay, these are the possibilities that it could occur, though it is rare, but still the chances are high as humans are writing all these things. So after containerization, what happened? Operation team developer just need to send one file, one configuration. Operation team will containerize everything into a single one and then make it a run. Okay, now operation team and dev team combine together and the DevOps will come into play. So before it's going to the main operation team, DevOps one, make it a single containerized one and then transfer it to the operation team. So for example, this Java app container, a single container now you are having. So no environmental configuration needed on the server. You just take it and download it. I'll show you how to do everything. So before going ahead, let's make our hand dirty using the practical. So first you need to have Docker in your system. I have a Windows based, okay. So Docker is in such a way it is built that you can use in Linux, Windows, and everywhere. So if I go to Docker install, you have for Windows, it is given a UI name as Docker Desktop. Okay. If I go here, you can use this one for Mac and Windows both. Okay. Docker Desktop. Setup. What is the setup? So install Docker Desktop. You just go click on this Mac. Okay. And then download the x86_64 version into your system. The moment you will download it, you will get this kind of Docker. You'll get an UI like this. Just taking a little time to open. Oh, it's already open. Here it is. So this is how it looks like. You have certain parameters over here, container, images, volume, build, lot of things are here. Okay. These are vague. I'll just delete it from now. So I have empty. Initially, you will get empty volume, empty images, and empty container. Okay, this is how it looks like initially. So once Docker Desktop installed, you go to your command prompt, cmd, open in run mode, admin mode, and do docker-v and check if it is showing Docker version installed, build. Yes. Clear how to install Docker? That's pretty much. Hello.
Yes, Akash.
Okay,
Yeah, Akash, it's clear.
that's good. Now, in the meanwhile, let's understand the further process. What is the further things? We looked into the Docker installation, Docker basic, why it is being used. Okay, what was the requirement of Docker come into play. Okay, for example, okay, we'll deep dive a little more. Actually, Docker container is always built on your local. Okay, on the hub or on the repository, you always push and pull images, mostly Linux images, because not mostly. Let's take an example of Linux-based images, okay? Because all are small in size. For example, I'm giving you an application, okay? So what does this contain? This application contain lot of layers, okay, into it. Layers like yours, what are the dependency required? Okay, what are the database required? So what you do, you layer all those into a single one that is known as images. So images basically contains a layer in which your base layer is the operating system on which you will run your application. Your top layer will be your application layer, which is the main one. In between, you will configure your database layer. Okay, a lot of based on the complexity of your application. But base layer should always be the operating system layer. So for here, for example, here it is using Linux. So Linux base image is at the end, and top one is your application image, application layer of this Linux base image. Okay, more about images, I'll go in detail. Okay, but for now, you understand when you have application, you convert into a image. Okay, how image, how do we convert? We'll look into that one. But the image look like in the layer format, where the base layer is your Linux on which your application will run, and the top layer is your application layer. Okay. So let's see this Docker images. Okay. There is a difference between Docker images and Docker container. People get confused. What do you mean by Docker images and Docker container? So see, Docker image is actually a simple image, static one. Okay. It's just an artifact that can be moved from one place to other place. Okay. But when it comes into your system, you actually need to run it. The moment you start the application, it became a container. That image will remain there. Whatever inside this image will come out and create a container. And that container environment is created. So it will be in running format. So Docker container always in the running format. Docker images is a static images which never runs. Okay. It's always there. But to run your application, you need to unpack this image to make it a container. And then you need to start this container to run your application. Any confusion? Images and container.
No.
In a practical example, if I have to give, you can see a pizza box. A pizza box is an image. Okay, but you have to eat that pizza, right? So you need to unpack that pizza box. So when you unpack it and when you take out your pizza, it's your container. And when you start eating it, it's in the running format. So that's how you can relate. So small differences. Container is a running environment for images. Okay, it's a virtual file system. We generally run our application on certain ports. So there are some port binding things happen, which we will look later. Okay. So let's go and understand in a practical scenario. So we looked into Docker desktop. That is the UI format where you will see all your images. And when you run your images, that images will come here and create a container. Okay. Pizza box will be there. Okay. Images will be there. Nothing will happen. Container will be created. So in one pizza box, you can put one pizza, take out, eat it, delete it, remove it. You can put another pizza in that same box, though we don't do that one, but it's still first understanding. So from one image, you can create thousands of containers. That's my explanation. If you have single box of pizza, you can put thousands of pizza into it one by one at a time. You can do it. Yeah, basically in Docker, you can do it at a time, but in reality, pizza box does not contain it. Okay, we are going out of topic. Let's come here. One website is the website from where you download the Docker application into your system. Other website is the public repository where, just like the GitHub, you have Docker Hub, where you will download the images, okay, not the container, images. Container, we build from those images. So if I go to explore, okay, you can create your account in this Docker Hub. Okay, I'll sign out. It's completely fine if I sign out. Even if you don't make it, still you can download and do your stuff. It is taking too seriously. So right now I'm out. I'll just go and click explore. So you would explore. Something is there to explore, nothing is there. Build now on build. Click on okay. This is an open source project. Okay, that's why it is showing the GitHub repository. You can also push your changes, do the open source contribution as well. I don't go there. Just go back. Docker AI. This is for Docker AI Expert. See, these are the images. Whatever you are seeing here, SQL images, this images, MongoDB images. Okay. Let's download. We have seen Ubuntu. Okay. Click here. You will see a lot of images of Ubuntu. Okay. One is the official one. You will get this symbol for official Docker official image. Other is being pushed by the verified publisher. I can also push from my end into this one website by creating my account, and I can push into this Docker Hub. Just like a GitHub. Imagine just like a GitHub. But I want official one. I'll click on this one. So when you will go here, come down, see, you get an option of tag as well. So tag is basically the versions. You can download a particular version as well. Okay. You can download 22.04, 22.25.10. Okay. I'll click here on tags. So if you come here and see, there's a Docker pull Ubuntu. Okay, this is the main file, your Ubuntu, and this is the tag. Okay, you can download this tag, make it a unique, a version, a specific version one. So based on this one, you can download any version of this one, Ubuntu. So I don't see any particular version number over here. What I will do, I'll just install Docker pull Ubuntu. Okay, I'll go here, Docker pull Ubuntu. Click using the default tag latest. If you do not provide any tag, it will pull the latest Ubuntu image in your system. Okay. Now tell me what I have. See, this is the latest one. Instead of latest, you can give the particular version number as well. If that version is available, it will download that one. If it is not available, it will not download. Okay. So right now we are in, we have downloaded the Ubuntu image. Can I say I have pulled the Ubuntu container? Can I say or can I not?
No,
Why?
because it's not in the running state, right?
Correct. So if commands always, okay, I have created another file. Where all Docker commands are here. Okay. I'll share with you guys. So all the Docker command we will look at here. Okay. Let's go back to our system. Okay. Docker images. You can see we have one image and with the tag latest, that is the version, always remember. It provide a unique ID to every image, okay, to make it a unique one. And when this Ubuntu was created 2 weeks ago, it doesn't mean it was created 2 weeks ago. It means it was some new changes were done 2 weeks ago. Okay. And the size is 117 MB. So this is one more benefit. Image size is low, so you can have that one on your system. It's pretty much portable. If I come here and see in the images, I can see my Ubuntu images here. Right now, this is the run button. The moment I'll click it, this image will run. So you can see I don't have any container here right now. Okay. Right now I'm only having an image. So I'm going to run it now. Docker run Ubuntu. See, right now it is showing nothing. That's okay. But if we come to here, and you can see a green signal over here. It means the container is now running. But, and okay, let's see this one too. It gives a random name to your container. If you do not provide a name, it will give a random name by itself. Container ID, just like a image ID, you get a unique identity number. Container ID also provide. From which image this container was built from Ubuntu image. Okay. Port number right now, there is no port number has been given. Okay. CPU utilization is none because. So tell me, is it running right now? Hmm?
No.
Right now it is not running. Okay. Why? Because if I do Docker PS, Docker PS will show all the running container. Okay. I now just unpacked it. Okay. I haven't started running it. I just unpacked it right now. So if I do Docker ps-a, it will show you all the containers which is available, stop or running mode. Right now you can see the status is exited. It means it was just run for a moment and then exit. Now if I want to run it, Docker run -it interactive mode, and then I'll click it. See, now I'm switched to Docker, this operating system, Ubuntu operating system. Now it's no more Windows operating system. How I can confirm you? I'll do ls. See, all the basic files I can get over here. Okay, I can create directory mkdir. I can do here anything I can do. I can do cd. I'll go to this. Where is that? Home. Okay, let's go to home. Is not here. Let's go to USR users. Okay, I'm inside user. I'll do ls again. So these are the things available here. Okay, you can go inside the root, any folder you can go, all the command I can do. What else I can do? There are a lot of things. See, let's see Vim. Let's create we can create a file over here. Touch. Let's make Docker. Now I'll do ls. See, a Docker file is got created. Okay, touch command is not working in Windows operating system. So you can see this is the root and this is the name of your, which one? This name. So this is a unique name, okay, which basically says that you are provide a unique root user for this Ubuntu system. Okay. Right now, I'm in Ubuntu. You can do all your functions, performance, everything you can do here. And if you want to exit, but right now you are eating your pizza. Okay. If I do, I can't do right now. I'll go to Docker desktop and I'll go to container. You see this one. This container is now in interactive mode. Okay. So another container got created from the previous container. Okay. Because I run Docker run, I did in 2 times. Docker run IT Ubuntu and Docker run. So both created 2 container, which basically one which is running in the interactive mode, other is in the static mode. If I do exit from here, I'll come back to my Windows, back again. And you will see both are stopping. Okay. And both these container are created from how many images? Only one images, only one image. Any confusion? Any questions?
No, Akash.
That's pretty good. I can look Docker PS. Let's see, is there any active? No, not Docker. Yes, hyphen A. And I have just 2 container which are now stop condition. Okay. To remove any container, okay, first if a container is running, you need to stop it. But for now, our container is already in stock. So we will do Docker RM means remove container. Okay. RM and the container ID or container name you can give. So I'll just copy this one and enter. And if I now do Docker ps-e, see now I'm having only one container. So if you want to create, we already know to run directly, you can create it, and to stop, you can directly stop it. Any confusion? Okay. What? Let's go and pull one hello world. There are a lot of images here. Go and I do hello world. Let's do Jenkins. We have studied Jenkins. Mhm. This is a Jenkins image. Okay. Now they will give you a command. You directly can pull the Jenkins. But apart from that one, they are also giving some other command JDK21. Why? Okay, what is this? JDK21?
So it is like a dependency that you're.
Yeah, it's a tag. Okay. It's the tag which actually says that this Jenkins image is will contain all the Java inside it, because to run Jenkins, you need to have Java in your local, right? So latest LTS, to use the latest LTS version, Docker pull Jenkins. This is the latest version. Okay. To use the latest weekly, this is the weekly one, which we are seeing right now. Okay. So this tag is important. Otherwise, if I install Docker pull Jenkins only, it won't install. Why? Because you don't have Java in your system. That's why. So it required to configure this whole. And the image name right here is Jenkins, not only Jenkins. I'll show you. That's unique. I don't know too, but if I'll do. And I press enter. What happens? It first checks in your local system and then it pull out the images. If it is not available in your local system, then it will go and take from the Docker Hub. So it pulled everything, everything has been completed. Okay. Now if I do Docker images, we have two images. One is Ubuntu, other one is Jenkins. The name is not Jenkins with the tag JDK21. If I do Docker run Jenkins, okay, press enter. Now see, it is started running. Okay. The thing is, it is running, and right now you cannot use your terminal because you need to exit this Jenkins and then you have to use. This is the secret key that they provide. If I go here and Jenkins, you can see. Okay, they have we got two images. JDK1, this is our one, okay, and JDK latest. Both are getting installed with this single tag. That's okay. Let's go to the container. You can see we have a single container, which is this. And one more thing, and this is in the running format. Okay, right now it is running. So it is using your this much amount of CPU utilization. That's fine. But right now I'm not able to use my other terminal if I want to use it. Okay. What you have to do in that case, I'll just exit for now, Control C. I got exited. The moment I got exit, this container will stop. Jenkins container. But what I want the container to continue running it without getting stopped, but I want to access the terminal as well. So we will use uh, command -d, which is a detach mode. So this basically runs your container, okay, and in a detach mode. So right now you can, with this one, you can access your this. You can access what? You can access your terminal along with the Jenkins continue, your container will continue running it. If I show you just Docker PS, right now no container is running because we have stopped. And now if I do Docker run -d, well, let's Jenkins. Press enter. If I go now here, see this one is running, okay, but what happening? You can use your terminal as well. I can use my terminal. I can do all my Docker command. Okay. Docker ps -ps. So you can see earlier it was not showing because no container was running. PS command will only show the active running Docker containers, not the stop one. And if I do Docker ps -a, it will show you all the Docker containers. Now, I got the answer of why we got two images. Okay. Instead, we downloaded one image, but we got two. So the answer is what happens actually when you use Docker pull, you pull the image. Okay. You pull the image. But when you use Docker run, what happened? You pull plus run, both get executed. So the mistake which I did initially, I Jenkins slash Jenkins colon JDK 21. Okay, this was the initial Docker pull I used, right? I used the Docker pull this command. And after that, to run this container, what I did, I used Docker run Jenkins. It means Docker pull extracted a particular Jenkins, which was of this version, JDK 21. But Docker run pull the Jenkins. If you do not provide any tag, it extract the latest one. So this command pull the latest Jenkins image and run it. So we did not run this Jenkins, rather we run this Jenkins. Okay, both are two different version of Jenkins you can run at the same time. So that's a benefit, and that's the thing we need to remember. When you use directly run, you will pull it and run it together. Okay, I can show you with other images as well. If I use Docker run hello world. Okay, hello world is a one of images which contain a message hello world. Right now, I did not pull it so far, but I'm going to directly run it. Let's see what happens. So it says unable to find the image locally. It did not find in my hub. So what it did, it pulls the image. Okay, pull is completed. Okay, and then it run it. If I do Docker ps -a, see, it pull and it run together. For 15 seconds it ran and then it is stopped. If I want to check the message, Docker um, container name is, I'll use the container ID instead of the name. Then -IT. IT means interactive mode. Something. Error. What is the error? Full access denied. This one repository does not exist. It require Docker logins. Okay, you require a Docker login for this one. Or may require. Hmm. So this container is not running. If I go and Docker container. Docker pull is denied because it's already available. Why just trying to pull? Yeah. With run, we use the image ID, not the container ID. That's the error we were doing. This is what? This is your container ID. And Docker run is itself used to run the image. So first I'll do Docker images. Okay. Now if I do Docker run IT interactive mode and the image tag, hello world, this one. Okay. From image, we run the container. Oh, what's the issue?
I think you should keep it as a -IT.
Oh, what I'm doing?
Docker run -IT. You just skipped like direct IT.
Oh, was okay. I was doing underscore. Did I? Oh, so sorry. Not hyphen it. I was not using the hyphen. I'm so sorry for that. So the moment I run it in interactive mode, it shows the hello from the Docker. This is the message. I was missing that hyphen. Any confusion?
No, Avish.
The next thing that we will look is the port binding. Okay, basically running a application in a single port. So how does it look like? Let me show you. Which image should I take? I have opened to. Let's run the Jenkins one. Okay, but for the Jenkins, if I go into the documentation, it require a volume. Okay, so right now I have not concluded the covered the volume section. So we'll come into that one later. We looked into the interactive mode, detached mode, how we will run the program in detached mode, and Docker pull, Docker run, all those things. Okay. Let's move forward. So how does it work? It basically, we have to just look we have to look into the simple one. Okay. So the kernel, whatever the application you run, all this application run on a hardware, and this hardware is actually attached with a single application kernel. Okay. This kernel should be the first layer and then your application one. That actually happens in your virtual systems. Whenever you use VMs, virtual system, that also create your Ubuntu machine, but those also create a new separate kernel, and then you run your application over it. But in our case, in Docker case, you do not, you use the kernel of your own system. The one I have showed you, I'm using this Microsoft one. Okay. Our bit, I used my another layer. Okay. And that layer of Ubuntu. And on that one, I'll use this application one. So the main operating kernel would remain the same. Okay. You will only use your application layer. Whereas in case of VM, virtual machines, you will use entirely a different kernel. For example, if I go if I want to use an Linux operating any application on VM, what I'll go here, I'll create another VM, entirely a different VM setup. And on top of that, I'll have to run my Linux operating system, Linux application. So if I come here, so here it is. I have to get this whole virtual machine. Then I have to go log in inside this one, and a totally different operating system would be allocated for me. Okay. Whereas in case of Docker, you don't have to do all this stuff. So that's the basic difference. You have to, you don't have to use the separate OS kernel. Kernel will remain same of your system. The only things that changes is the application one, application layers. Okay. What is the benefit? First, Docker images are much more smaller. If I use the VM of Linux, it's much more heavier compared to the Docker one. It was 117 MB. Then speed. We quickly get into our Docker, Ubuntu system compared to if I go and install another VM, that will take time. And then compatibility, so which is basically run on any OS system compared to your host. No matter what is your host, you can run on any OS system. These are the benefits. Any confusion?
No.
Okay. So, so far, we don't have any port to our container. Whatever the container we are using, those containers do not have a single port. Now to run any application, you require a port. Okay. So you have to do a port mapping for that one, which is pretty much easy. I'll show you. If right now I have Ubuntu, okay, I'm going to allocate a port to this one. Okay. So let's go and do it. Docker. Okay. Run. -P is for the port one. And suppose if I want to give 8080, the port comes in the two way. One is your host port and one is your application post. Okay. First one is the application one, from where basically host one or application both are kind of a similar. This one, that the actual port of your Ubuntu, and this is the port on which you want to run your application. Okay, so this port you can easily change based on your uh, compatibility. For example, I'm giving you one more example. If I come here, um, see, Jenkins generally, if I go into the documentation, so Jenkins, here it is running on 8080 port. Okay, I have to run the Jenkins, sorry. So Jenkins is running on 8080 port, but if I want, I can run the Jenkins in this port as well. Okay, if it could be 8080, you can run on 8080. I can run on 8090, I can run on 8900, 9000. Okay, so let's run Jenkins. For now, I'm just running on 8080. Okay. And then the image name, whatever the, okay. This is the API port, okay. Generally, it happens in only in few applications. You have to give the application port as well as the API port. So I'm just copying this one. -P for API, right click and use the code. And then after you need to provide the, here it is saying to restart on failure. If it get failed, you can restart. We are not going to do this one. And we can use the image name, okay, which was our Jenkins along with the tag. So Jenkins JDK 21. If I don't use JDK, it will take by default the latest one. Can I copy title from here? Yes, I can copy. Press enter. So what it is saying, the port is not available. Why? Because this port is already being mapped. Okay. So what I can do, I'll change the port. It happens. Okay. If this port is being already mapped with other application, you may not be able to run it. Let's see this one. So I'm able to run my Jenkins on this port. Okay. I'm not running in detached mode. So that's why I'm not getting the terminal. So what I'll do, I'll just copy this secret key. Copy. It is 8090, right? I'll go to my application. Localhost 8090. Okay. See, I got my Jenkins. I'll paste the secret key, install it. Okay. Now you can do the further steps. Okay. You got your Jenkins here running. Same you can run in the detached mode as well. It's totally on you if you want to run into. I'll do Control C. Okay. Let's do JDK. It was JDK 21. Right now, I ran this one, latest one. I want, if I go to container, I can see which one just 1 minute ago. This one. So you can see the ports, show all the ports. If I click on show all the ports, so it's showing both the ports. 8090 for the application port and the 5000 is for the API port. Okay, so we can run DK21. -D port number and JDK21. Okay. So, okay, the issue with this running in detached mode initially that you won't be able to get the secret key. So even though this is running, if I'll do Docker PS, see, it is running. Okay, our JDK, this one, running, and this one is also running. And what port we mapped for this one? Okay, we have done couple of things that we need to fix over here. Okay, 8090 already assigned for the Jenkins, which was this one. Okay, if I'm running JDK 21, okay, which is a different image, and if you want to run a different container out of it, you need to assign a different this one. So if I do come here, the same port got assigned to the same Jenkins. Got it. The host 8090. So the same one got assigned to this one. Okay. So instead of that, we need to change the port over here. Okay, then we would have been getting this one. Let's see with this secret if it's running or not. So it is not running. Okay. Why? Because on the same port, currently I'm running this JDK 21. Okay. And it has different secret key. So I have to run that one in not detached mode to get the secret key. Any further questions? Any questions? It might look a bit tricky to get all these things.
No, Akash.
So what we did in a summary way, if I have to say, we pull the image from the Docker Hub. Okay. From the Docker Hub, we pull all the images, Jenkins image, Ubuntu image, Hello World. We run it in a detached mode, interactive mode. Okay. Then we did the port binding. This is known as port binding. We are basically -p is changing the port for your local one. Okay. 8090, 8091, any port number you want, you can give along with this one. This one also you can change. But you should not change this one. Okay, because this is the initial one that application is originally run. Okay. So every images that you install from here, you will get this one port number of that image. Okay, so on that port, you need to bind your port on which you want to run. You can simply run on that same port, or you can run on a different port. It's totally on you. Got it? So this is just the basic class of this Docker. We will be having one more class, which will be our next class, where we will be going little bit more advanced topic. Okay, like the volume mounting. Okay, so we will cover. I have one application, so that application we will convert into a Docker. We will create a Docker file. We will see how to create a Docker file. We will convert that Docker file into the Docker image. And then we will push that file into the Docker Hub so that you guys can pull from your system that one and run that application directly. So that we will do in which is the most practical application that company or organization do. Apart from that, one advanced topic that is Docker volume. We will see the volume mounting. How do we do that volume mounting? And we will also see the Docker networks. We will establish network between our Docker application. So these things we will do in our next class. Okay. So right now I can share this PDF, but it won't help much because what we have seen Docker images command. Okay. To remove image, you use RMI. If I go, but before using that image, you need to delete the container. So if this container is running, first you need to stop this container, docker RMI, get the docker, stop. So this will stop your container. Then you can do docker RM to remove this container. Mhm. And then you can do docker RMI to remove which image it was made up of. So you need to check D304. No, it might not be available right now. If I go to images, D3, that image. Okay, that has been deleted. So before deleting, you need to check from which image it was created. Yes, it was. If I do this, let's try this one. Untagged. Then has it been removed? Yeah. So that was created from the latest one. So it has been removed now. You can see. Now we are left with only 3 images with this tag. And all this containers belongs to all these 3 images. Understood? Docker, how to remove any images, just use RMI. But before that, you need to remove the associated containers of that image. Docker prawn will remove all the unused images. If the image is unused, it will remove that one. Build, we will see in the next class. Docker ps-a for all. We have looked this command, this command, this command. Detach mode we have seen. Docker run name. If you do dash dash, you can rename your container name. Okay. Port binding, we have seen up to this much. Okay. Post. the one that you want, container post, the one that it comes along with it. Furthermore, we will see in the next class. Okay. Any
So in the
confusion,
next
any
class,
question?
you will,
Mhm.
Akash, in the next class, you will explain about how to write a Docker file and everything, right?
Yes.
The
Yep.
components in the
Components and
Docker
everything.
file.
Yeah.
Okay.
Docker file get complicated based on the application, how complicated your version is, how much dependency it require. Okay. I'll try to get 2-3 applications and try to build the Docker file of that one so that it will be easy for you guys to handle it. Okay. Any further questions? We'll do complex topics in the next class.
Okay, got it. Okay.
So far, just practice this, whatever we have done. It's not much. Then we'll cover all these things in next class as well. Stop the recording.